Okay, welcome along to In Conservation With. My name is David Lindo, also known as Urban Birder. It's probably our last one this year, this particular series, should I say, because it ends in April and we start up again in October for the fourth season. But what a great evening we have planned for you. We've got Rick Prum with us, who's going to be talking about a subject a lot of us know a bit about, but not a lot about, and that is the subject of sex, but bird sex, not sex in terms of humans, even though I'm sure there's some similarities there. And I must also say that tonight is sponsored by the Leica Sport Optic people who produce some top quality binoculars and optical equipment for birders, as well as the Diputación de Cáceres, which is a northern region of Extremadura. It's a northern region that they actually look after. So thank you very much, guys. And Richard, Rick even, it's great to see you. I've known you for a couple of years now, but before we actually talk about how we know each other, let me just quickly ask you, how are you and where are you?
I'm doing great. I'm here in the one of the first sunny days of of the spring in New England. I'm in the state of Connecticut.
And
In the United States.
Say again? The United
In
States.
the United States, yeah.
Of course. We met maybe 3 years ago now, I think. It's obviously before the COVID scenario, and we met in Colombia. And I remember, you've got a very effervescent personality, and I remember I'll never forget you. But also, you gave a great talk, which made me think, God, I'd like to have you on In Conservation with talking about this. And it's taken me a long time to actually find you, but thank you so much. But
it's a pleasure to be here. And I remember that meeting in Cali, Colombia, the Colombian Bird Fair, and it was a good time, and nice for us to meet on neither of our home continents, right?
Exactly. But let me just tell you guys, you Zoomers, about Rick, because you may not actually know much about him. You are, William Robinson Co-Professor of Ornithology at Yale University and the Curator of Ornithology in the Yale Peabody Museum of Natural History, no less. And you are an evolutionary ornithologist with a broad interest in avian biology. And you are, of course, a lifetime birder. And I knew that when I actually met you, you were out there birding. You've researched many topics in bird biology, including avian phenology, behavioral evolution, feather development and evolution, and structural coloration and sexual selection and dinosaur origins of birds. I mean, we've got 5 or 6 different subjects there where we can have you on in future in conservation with talking about. You conducted fieldwork on the birds of all the continents, and you've studied fossil theropods in China. In 2017, you published the book, The Evolution of Beauty, which I think you may have a copy.
Oh, sure. Always. Right at hand.
And I suggest you guys go out and get that book because it's fascinating, and it was named one of the top 10 books of the year in the New York Times, and was a finalist for the 2018 Pulitzer Prize in General Nonfiction. So we're talking about a real piece of work in terms of great work. And you've been awarded the MacArthur, the Guggenheim, and the Fulbright Fellowships. So, you come well awarded. I'm in great company. We're all in great company. Thank you very much for actually being here tonight. But it's this whole idea of bird sex. It's really interesting because, this time of year is spring, people are out, birding, and they're seeing. I mean, the other day I was actually watching a pair of European greenfinches mating, and that sort of 2-second scenario, the cloacal kiss as they call it. And I remember once a few years ago, I was filming with this young kid, this 17-year-old kid who was farming quail, and the idea was that I was telling him about what quails do in the wild, whereas he was telling me about the quails in his garden and how he actually cultivates them. And he was telling me, "Oh, I wish I can have sex like a quail. They have sex, 60 times a day or what have you." And I said, "Yeah, but what, for 2 seconds each time?" But please fill us in.
Well, great. I'd be happy to. I mean, today I'm going to focus on, we'll get to bird sex, but I'm going to focus on the consequences of sex, which of course are mate choice and beauty, which is really, central to my science. We are, been studying this for a long time, and so I'll get right to it with my slides, right?
Absolutely. And don't forget, guys, if you want to watch this in its full glory, then watch it on speaker view so you have the whole image filling your screen.
Great. So it's great to be here. Thank you, David, for the invitation, and it's fun to be able to share this aesthetic view of bird sex, I guess we could call it. Now, as David mentioned, I'm a lifelong birder. Started birding at the age of 10 and never considered anything else. So what I want to do first is to document or tie this in as a kind of bird watching science, right? This is a science that is informed by both my personal experience and my ongoing interest in bird watching. A lot of scientists, actually, I know scientists who are trying to eager to keep those separate, but me, I'm actually really about moshing them together. And so to earn your credibility, I want to start at the beginning. And yes, that's me back in elementary school, right? And the critical feature of this, there's lots of embarrassing things about that picture, but critical feature, of course, are the glasses. And those glasses were critical to my birding story because I got my first pair of glasses in 4th grade at the age of 10. And in just a few short months, I was a birder. I think the earth, came into focus, and all my amorphously nerdy stuff that I was doing was suddenly found a target, and that was birds, right? So I've never considered really doing anything else in my life, and now I'm unfit for any other sort of employment. So luckily, there's things like ornithology for people like me to go. But when I did my research, in grad school, I really tried to combine my bird watching with science, and that led to lots of work on mannequins, South American and Central American frugivores that we'll see later on. And so this is me, in the Andes of Ecuador, recording birds on an old reel-to-reel Ewer tape recorder in the 80s, and all that led through lots of different kinds of research to my messy office here at Yale today. I've had the pleasure to work on all sorts of things, including phylogeny, the development of feathers, the color, like the physics of these optical blues in this banded continga, or the chemistry of the pigments, of the carotenoid pigments and its purples, all sorts of things. And indeed, I used to think that it was just a lot of topics that Rick was into. And then in the recent years, I've realized that it's actually a lot of it's about one important topic, and that is the beauty of birds. And by the beauty of birds, I mean not the beauty as we see it, but the beauty as birds see it. And basically to the idea that birds are beautiful because they're beautiful to themselves. Oops. And dedicated to the scientific question that this kind of beauty can be studied in a scientific way. And so to start with the true challenge of avian beauty and its relation to sex. Let's start here with a video. This is Superb Bird of Paradise, which was filmed in New Guinea by my former student, Ed Scholes, now at Cornell University. And we'll see in a moment, this is a polygynous bird where the males do no part in reproduction except mate. The females do all the work. But they visit among available males. And there's the female approaching the male at close distance. And if you listen carefully, you can hear the wing snaps. What we have here is a complete transformation of the image of the bird with this incredible orb of iridescent colors and super black feathers. And so we've been studying this in great detail, including both the optics of those colors and the super black feathers, which I'll could talk about it another time. But what this shows is the depth and profundity of how beauty and selection for it through mate choice has influenced the evolution of birds. And so what I really am doing it scientifically is trying to put the subjective experiences of animals, that is, what it is like for the animal to actually have an opportunity for choice and to use its sensory system to do so. And of course, if we were studying bats or moles or these more myriad fish that sing songs with electricity, we would have very different kinds of perspectives. But since we are very visual, color vision, and also acoustic like the birds, we relate a lot to the subjective experiences of birds. So in that sense, we are particularly appropriate for studying the subjective experiences of birds. Now, in my science, in order to make this science, we have to make it we have to define what I mean by aesthetic evolution, right? Evolution that is about beauty. Evolution is an emergent, aesthetic evolution is an emergent consequence of sensory perception, cognitive evaluation, and choice. And in those cases, when birds have when organisms have the capacity to perceive, the capacity to choose, and then the opportunity, social opportunity of choice, they choose features that evolve to match their own perceptions. And indeed, their perceptions and those features co-evolve. So in order to turn beauty into a scientific topic, we could state that beauty is not merely attraction, but a co-evolved attraction, in which the form of the attraction and the display and the desire for it have shaped one another through time. So we can see here, there are things like the cock of the rock and the song of the wood thrush that are clearly about sex. There are things like the socially monogamous or monomorphic plumage of the blue jay, which is about social communication. You've got cute baby birds that at least cute to their parents, right? Of this finch and cuckoo, and then lastly flowers, which are another kind of aesthetic feature. So, but today we're going to be focusing on beauty that's derived through sex, through mate choice. And of course, a lot of these ideas go straight back to Charles Darwin, a great contributor to the core ideas of evolutionary biology. And of course, after publishing The Origin of Species, Darwin had a few persistent intellectual problems. He had no theory of genetics, no articulated theory of human evolution, and no theory of what he called the origin of impracticable beauty, beauty that seemed to cause a problem for survival and therefore didn't fit into his definition of natural selection. Well, he was already perhaps the most famous scientist in the world at that time, but instead of just sitting on his laurels, he actually turned around and wrote another book about this impractical beauty. And that was based on his solution to the problem he posed to Asa Gray after The Origin. The sight of a feather in a peacock's tail, whenever I gaze at it, makes me sick, right? And I think if you look at that picture, you'll share my opinion that Darwin looks a little sick there, right? He was troubled, intellectually troubled, and a lot of that intellectual trouble led to health problems. But instead of just resting on his laurels, he actually wrote an additional book called The Descendant Man and Relation and Selection in Relation to Sex, where he took on two of those problems: the origin of humans and beauty, the evolution of beauty. And he proposed two mechanisms of sexual selection. One was mating competition, usually within males for access to mating opportunities, and that led to the evolution of armament, like large body size and antlers or horns. But then mate choice led to the evolution of beauty. That is where one sex selects mates and of the other sex, and leading to the evolution of ornament in contrast to armament. Now, what's fascinating about Darwin, we don't often, although he's often cited, he's not often read at this point. People are surprised to find that Darwin's description of mate choice was explicitly aesthetic. That is, he talked about the behavior of animals using the qualities that we associate with art and human artists. So he called mate choice an aesthetic faculty, or a taste for the beauty, a taste for the beautiful, and that organisms made choices on the basis of standards of beauty. And he also said that the most refined form of beauty may serve as a sexual charm and for no other purpose. And so in that case, he meant that no other adaptive purpose. So in this case, that natural selection and sexual selection by mate choice were distinct features and distinct mechanisms of evolution. He also had a co-evolutionary theory. We'll see the Argus pheasant in a few minutes, but he wrote that the Argus pheasant acquired his species gradually through the preference of females during many generations for more highly ornamented males. The aesthetic capacity of females advanced gradually or through exercise or habit, just as our own taste is gradually improved. So here he had a combination of male display and female mate choice co-evolving, changing each other over time, mutually evolving. So Darwin's idea was of male-male competition structuring the sexual world at the time was so congruent with Victorian and Western society that it was a big winner. But his idea of mate choice, in particular that female choice was a natural force in the world, was a big loser. And one of his main antagonists, surprisingly maybe, was Alfred Russel Wallace, the co-discoverer of adaptation by natural selection. Wallace's critique of Darwin's idea of mate choice was so devastating that mate choice disappeared for a century from science, right? In other words, he was incredibly effective at it. And that was quite devastating to Darwin. Now, Darwin and Wallace argued about this until Darwin's death, but Wallace lived until the dawn of the First World War, really, and so had a tremendous impact on what evolutionary biology became, right? So in a book on various aspects of evolutionary biology, Darwin or Wallace wrote some of his core problems with sexual selection. He said, in particular, that sexual selection was neutralizing, or natural selection was neutralizing sexual selection. And he wrote that the only way in which we can account for the observed facts, that is ornament in nature, is by supposing that color and ornament are strictly correlated with health, vigor, and general fitness to survive, right? And of course, what's fascinating is that this is the guy that killed sexual selection, but here he is describing what most of us actually think of sexual selection today, which is that ornament is a way of getting better, right? It's a way of getting males or mates that are more healthy, more improved environments to raise your young. And this idea of this strict correlation between color and ornament came originally from Wallace. How did he get away with that? Well, he actually subsumed or combined the elements of sexual selection that he liked, such as this, and he called it natural selection. So he was able to use Darwin's Origin of Species to argue against Darwin in the Descent of Man. Now, Darwin lived to be until 1883, and here, just 6 years after Wallace's death, or after Darwin's death, Wallace wrote a book called Darwinism, in which he hoped to capture this intellectual movement. And he wrote, addressed sexual selection right in the introduction, saying, even in rejecting that phase of sexual selection, depending on female choice, I insist on the greater efficacy of natural selection. This is preeminently the Darwinian doctrine, and I therefore claim for my book the position of being the advocate of pure Darwinism. Here, Darwin has been dead for 6 years, and Wallace is claiming to be more Darwinian than Darwin. Well, it's been 140 odd years since then, and I'm still pissed about this. And I hope that you will too, because what I think happened is that Darwin won the battle over credit for evolution by natural selection, adaptation by natural selection, but Wallace won the war over what evolutionary biology would become in the 20th century, which was overwhelmingly an adaptationist view, the idea that the greater efficacy of natural selection would dominate other forces, right? And this is a particular way of taking beauty in nature and turning it into a kind of utility, right? And so what I'm trying to do is to restore that authentically aesthetic consequences of mate choice that are really authentically Darwinian. To give you an idea of how to think about this, I'm going to propose to explain it in terms of the value, comparing the value of money and the value of beauty. Where do they arise in nature? Well, on the old days, the value of money used to come from the gold standard. Every dollar had value because it stood in lieu of a tiny piece of all the gold that's piled in Fort Knox, right? But we now know that all money from dollars to Bitcoin has abandoned the gold standard. There's no gold, right? And there's still gold bugs in the world, economists who think that this is a great problem. But what happens? Well, in the words of Paul Samuelson, the value of money is a social contrivance, right? And it is where people agree on what's valuable. And so in biology, what does this have to do with biology? Well, Wallaceans and most of my colleagues in evolutionary biology are on the gold standard. They believe that the value of beauty is not in the beauty, but in some other benefit, right? Some other extrinsic possibility. Good genes, good food for your kids, no sexually transmitted diseases, etc. Right? But in the genuine Darwinian world, there we are not on the gold standard. The value of beauty is a social contrivance. It's an evolved feature in which choosers and beauty co-evolve with each other in some arbitrary direction. Right? How might we think of this? Well, one way to call this is beauty habits. Right? If organisms have the capacity to see or to observe, the cognitive ability to evaluate, like something, and then the social opportunity to choose, then beauty happens. Then beauty will evolve. Right? It doesn't require some special additional benefit like good genes or direct benefits. So in order to think about this scientifically, I hope you'll all remember this picture of Wallace with the leprechaun hat, right? Because what I'm trying to say is that these adaptive views of sexual selection are like imagining that every beauty in nature, every peacock, for example, is like a rainbow leading to some kind of extrinsic benefit, like a pot of gold, right? And in that pot of gold, you can see our DNA, good genes. There should be worms or maybe condoms to indicate no sexually transmitted diseases, right? And so how likely is this to be? Well, I think the leprechaun tale is a good guide, right? If you see a rainbow, is the beauty of the rainbow merely for its own sake? Or is the beauty an indicator of some other benefit, like a pot of gold? In this case, I think robustly, we ought to think as scientists, we ought to believe not in the leprechaun, but that the beauty of the rainbow is intrinsic to the rainbow. So what this means is that beauty happens is the null model. Scientifically speaking, we should stick with the arbitrary nature of beauty until proven otherwise by evidence of good genes or direct benefits. So that's my sciencey intro. And I want to talk now back to the birds. Of course, and since this mate choice is about reproduction, all these stories are couched in sort of the reproductive biology of the birds. This in particular is an Argus pheasant. It's actually this image is being taken in a zoo, but the Argus pheasant is found in Indonesia and Peninsula Malaysia and South Asia. And you can see the male is almost 2 meters long and the female is quite a bit shorter, but still with some elaborate tail feathers there. You can see that the male is displaying to this female, and in a moment you'll see a similar kind of transformation. He's going to open his wings and display those incredible secondary feathers, which are almost 1 meter long, and which have unusual spherical patches on them. Those spherical patches are made out of pigments, right? Or some melanin pigments. But you see they have a white highlight on the top and a dark smudge below, which gives them the appearance of three-dimensionality. So this is like 300 golden rufous balls in the air, suspended over the female. You can see the male's head is tucked in under his wing there, so that she can, so he can speak here. So what's going on to the female here? Well, the first Western scientist to observe this in the wild, William Beebe from the Bronx Zoo in New York, described it as saying, well, I'd like to believe what Darwin says about all this, that these females are making aesthetic choices, but it's clear to me watching this display that whatever aesthetic impact might occur from this display is absolutely wasted on that little hen, right? So he imagined that the female was basically inert, impassive, right? And I think that reason is, of course, that he's misaligning her interests. She's actually the co-evolved agent that's produced this. If we go to a great art show, we don't see the the collectors and curators and agents weeping at the sight of the new art, right? They're sitting back going, "Huh, I wonder if I like that." And that's what she's doing. She's perceiving it, and it's only because the vast majority of these males fail to mate, fail to earn any mates at all, that these incredible beauty has happened. Right? So let's look. So here, an example is a photograph of the spherical balls that make this, and you can see that this is an optical illusion. It is creating the misimpression of three-dimensionality on a flat surface by creating this white highlight, like the light shining off my forehead or my glasses, and a shadow, like the shadow cast under my chin. It shows that I'm illuminated from above, right? And that creates this image of three-dimensionality. So that kind of optical illusion is impossible to imagine evolving as an indicator of quality, because no specific quality information on the part of the male growing the feathers could actually produce this particular combination of features. There's actually another optical illusion. You can see that the spheres get larger toward the tip of the feather than at the base. If we look at that foreshortened from the perspective of the female on the right, you can see that they converge on 300 golden balls, all size, right? So this is a second layer of optical illusion, and this quality is something I think is impossible to explain by anything other than aesthetic impact, than the fact that there's something that females like. Now, before going on, I'm going to talk about a lot of aesthetically extreme species that are mostly polygynous. That is, the female does all the work and the males just mate. But there are, of course, lots of varieties of beauty in the birds of the world, and lots of varieties of family and family organization, right? So on the top, we have a bunch of species that are sexually monogamous, but still with brilliant ornaments. So this is where males and females both have ornaments and both have choices and are both making choices, right? So this isn't just about female choice. And then in some species, like in the bottom row, are polyandrous. That is where each female has a territory or and multiple male partners, right? So here we have complete other ways to organize it. And in these cases, the females have beautiful plumage, sing the songs, and in the case of Jacana on the right, actually have weapons. So they have armaments, so female-female competition, another source of sexual selection. But we're going to continue back to those aesthetic extreme polygynous birds, and we're going to get back to South America, my favorite bird continent. And this is an amazing bird found in the Chocó, or western slopes of the Andes in Colombia and adjacent Ecuador. This is a mannequin male at his lek display site. It's called the clubwing mannequin because of his really oddly shaped feathers. And the clubwing mannequin is called clubwinged because of these thickened secondaries, the shaft of the secondaries. But it's an unusual bird because that sound is not a vocalization, it's a wing song. This bird is singing with its wings, right? Which is extraordinary because birds have been singing for probably something like 150, 170 million years, right? And so this bird has almost entirely given up vocal advertisement to sing a new kind of song, a song with duration and tunage, or some tuneful song, but with his wing feathers. So it took us about 20 years to figure out. This is work of Kim Boswick, one of my former students, also at Cornell. And it took us about 20 years to figure out how this bird made it, how it makes it sound. Here's some of the first high-speed video ever shot in the wild of bird behavior. This is at 500 frames per second. You see the feathers are oscillating over the back of the bird, right? And this led us to examine how those feathers could make that sound. And here we have the thickened feathers, and you can see the fifth secondary has a bent blade and leans over and rubs against the sixth secondary, shown in the lower right. And that sixth secondary has a series of bumps. So as the feathers vibrate, this blade is rubbing against the thing, like bowing a violin or clipping or running your fingers across a comb. And that is a form of sound production called stridulation, which is unknown in the bird. So beauty can be innovative, right? And here's that illustration showing how that works. But in subsequent work, Kim Boswick showed that, or asked the question, really fascinating question, is beauty only skin deep? And the answer is no. In order to make those beautiful wing songs that female mannequins prefer, the male has evolved incredible thickened wing feathers or wing bones. Here are the humerus, radius, and ulna of the wing in this CAT scan. And here they are in cross section. And you can see that the humerus, the radius, and the ulna are all solid. That is solid like ivory. And that's a big deal because, you know, even T-Rex and Velociraptor have hollow forelimb bones, right? So this is an aspect of avian biology that goes back before birds to the dinosaurs, right? And so this clumbing mannequin ulna on the far right is extremely different from even other closely related mannequin species. Of course, this kind of investment, extraordinary morphology, could be interpreted as an informative handicap, the idea that costliness is associated with honesty, right? But I became very interested in this and trying to think, well, what about the females? The females of clubbing mannequins, what do their wing bones look like? Well, in fact, the female clubbing mannequin wing bones are exactly the same size and almost as same shape and almost as large as the male wing bones. In other words, the female's wing bones are messed up in the same way, but they are not singing the songs, right? So clearly, when you see clubbing mannequins in the field, males fly less well. We don't have data yet on that, but what that means is that females are also paying the costs, even though they don't recoup the value. So the reason why these flute-like bird ulnas are found throughout the rest of birds are that they work really efficiently in flight, right? But these birds have both, the clubbing mannequin has able to, in order to sing a song, has transformed its wing bones, but female wing bones are also similarly transformed. And the result, of course, is that they're less able to fly. So why is this important? Because I think this means that sexual selection can be decadent, right? That females, by choosing the males they prefer, actually leads to the degradation of everybody's quality, right? So here we have a male singing a song, and when the female looks at that male and picks the male he likes or she likes, then her offspring will inherit the features that this male had in order to sing that song. That's the indirect benefit of mate choice that drives sexual selection, right? By having a sexually attractive offspring, this female can further her interest. However, it turns out that her female offspring will also have weird wing bones. Why is that? It turns out these wing bones develop in the embryo before the embryo becomes either male or female. So there isn't any possibility of getting rid of that weird wing bone in her daughters, which means that her daughters will also be worse off, right? And so this kind of mate choice leads to everybody in the population getting worse, right? Well, I hope I've convinced you that there's aesthetic agency of mate choice, that birds are making choices, and those choices are based on what they like, and that this aesthetic force creates all kinds of interesting new features of avian biology. But once you recognize that birds are actually choosing, then that leads to new insight into some classic questions in evolutionary biology. And one of those has to do with duck sex. And it turns out that duck sex was studied in my lab by Patricia Brennan, now professor at Mount Holyoke College in Massachusetts. And she came with an interest in studying duck genitalia. And I thought to myself, well, I've never worked on that end of the bird before. I'm sure I'll learn a lot. But in fact, what we learned transformed my view of topics I hadn't really imagined. And this comes to the problematic subject of duck sex. Why problematic? Because, well, most aspects of duck biology are vanilla, typical of other birds, right? Female ducks, like this female mallard, choose their mates on the basis of displays, like the green head and the quack, quack, quack that individuals like. But in particular, duck sex is problematic because as the pair proceeds to nest in the spring, a good large cohort of unpaired males will attempt to force copulations. This is essentially rape in the bird world, right? And they will force copulations in order to try to get parentage from that female's eggs, right? And this leads to sexual violence that is harmful to ducks and actually can even lead to their death, right? This is a problematic, difficult topic. However, one of the fascinating things about it is how females have responded, and that's what we'll talk about today. Now, this whole aspect of duck sex is made, or interesting aspect of duck sex is made possible by the fact that ducks still have a penis. And I say still have, how does that work? Well, it turns out that the penis evolved once in the common ancestor of all mammals and all reptiles. And reptiles have a penis. In some cases, they have two. In, for example, in lizards and snakes. But the penis is actually primitive and present inside modern birds, but has been lost in almost all birds except ostriches and their relatives and ducks. And here we see a whistling duck with a prominent dangling penis. And the penis of ducks is extraordinary in lots of ways. Not least of all, it can be very long. Here's an Argentine lake duck, which I failed to see on my trip to Argentina 2 weeks ago, but I'm hoping next time. But this is an Argentine lake duck in which the male's penis is longer than the duck. So what's with that? Well, it took Patty Brennan to come to my lab to try to understand what was going on, the female view on this situation, to discover why this penis has grown or has evolved to be so large, and other aspects about the biology of this. Further background information: the duck penis is extraordinarily odd, or the avian penis from a mammal perspective. It's corkscrew shaped. It's stored inside the body and comes out only during copulation. It has lymphatic erection instead of blood vascular, which means that, as we'll see, that the erection is almost instantaneous, right? And also immediately over. It has, instead of having an enclosed urethra, it has a sulcus, a groove that runs around the outside. Whoops. And then I guess I can't use my mouse. And then it comes in smooth, ribbed, thorny, and even elaborately bristly varieties, right? And so how does all that work? Well, it's quite amazing that it took until 2010 for a scientific paper to actually be published on how the duck penis works. And that was our work. And what we did was go to a duck farm in California, where they were collecting sperm from one species of duck and using it to artificially inseminate another to get hybrid ducks that grow at more vigorous rates. So this is a fascinating opportunity to study the duck penis in action. Now, in science, we aim to affect people's experience in ways that are absolutely memorable. And the next slide will change your life because you won't ever be able to forget it. This is a high-speed video of a duck penis captured at the duck farm in our study. And here you can see the male duck mounted above the female. We made it so they can't intromit, and there is the penis. Now that is over 20 centimeters long, and the erection takes place in 1/3 of a second. And as you can see, that sulcus, which a lot of Victorian scientists had derided as a non-functional, works just fine, thank you, at delivering sperm. And also, I want to point out that since we're using the metric side of the ruler, so that means that this is indeed science, right? So, and you can see that the once the duck copulates, then the penis erected in 1/3 of a second, ejaculation takes place, and after that, it takes actually some period of time, probably on the amount of hours before that male can actually copulate again, right? So that's something that's not happening in other birds that have lost the penis. So what Patty studied was the anatomy, the anatomical and evolutionary response of the females. So on the left, we have a species with almost no forced copulations. And you can see that the penis there, these are dissected out of bodies. The penis is small and the vagina, the oviduct of the female is very simple. But in species with high rates of forced copulation, we see that the penis, it becomes elaborate and also the surface becomes complex and the vagina becomes highly convoluted. What's with that? Well, she dissected out lots of these in many species. What we documented was that the inside of the entryway to the avian vagina, we see a series of blind pouches or dead-end cul-de-sacs, and then clockwise spirals. Now note that the penis is actually counterclockwise spiral. And so what this means is that the anatomical innovations in the duck vagina are actually anti-screw devices. They prevent intromission during forced copulation. We were able to demonstrate that. We couldn't actually observe it because the whole event takes place in a third of a second, and we couldn't actually get forced copulation to take place in, say, a CAT scan in a third of a second, right? And so we don't have much data directly on what's happening inside the bird. However, we were able to test it by going back to the duck farm with a series of glass tubes. So these are glass tubes blown by a man at the Yale glass blowing shop in the chemistry department. And so one of my favorite parts of the book to write was the scene where I described going to the glass blowing shop and telling the man that we need to make artificial vaginas for ducks. And so I'll let you explore that. But what we have here is a straight tube that's and curled tubes, or tubes vary in shape with the same diameter. This is counterclockwise coiled or right hand coiled like the male, and this is shaped like the female, and then with or dead end cul-de-sac, or a blind turn. What we found is presenting these tubes back to the ducks and having the ducks erect their penises into these tubes, that they erected just fine in the male-like tubes on the left, and that they failed in over 80% of the cases to intromit entirely on the right. So this was a good testable evidence that female vaginal morphology had evolved in order to prevent successful fertilization of the eggs during forced copulation. And what does this all boil down to? All this boils down to the fact that sexual autonomy matters to animals. There's something it is like to have free choice, and there's some evolutionary consequences when that choice is violated by sexual violence, right? And so females have evolved these countermeasures that, although they can't avoid the direct harm of sexual violence, they can actually prevent these forced copulations from being successful most of the time. And we show that other data show that in species where 30–40% of the copulations are forced, extra pair copulations, that only 2 to 5% of the offspring in the nest are actually sired by males other than the primary social partner. So what that means is that females have essentially a FDA deployable, FDA approved deployable birth control device that they can use and whenever they need it, right? And that has evolved because sexual autonomy matters, freedom of choice matters. If the female mates with the male she likes, he has the green head, the quack, quack, quack that other females are going to enjoy, and she and her offspring will be sexually attractive. But if she's forcibly fertilized by forced copulation, then that male will either be random or one that she specifically rejected, which means that anything she can do to assert her freedom of choice will evolve because it will defend her or it will be supported by other females that have. So what this means is that female choice as itself can be a force for the evolution of freedom. And that's a deep insight into biology of birds, right? Now, in the case of the arms race of the ducks, we see that vaginal innovations create selection for more complicated, larger penises, et cetera, et cetera. So we have like an arms race between males and females. But it doesn't always work that way in birds. There are other cases, and one of them is another polygynous, aesthetically extreme species, the bowerbird. The bowerbird is found in Australia and New Guinea, 20–25 species, and they are frugivorous and also polygynous, right? Female does all the nesting, but the male builds a bower. The bower is not a nest, it's actually a seduction theater. right? It's got one seat in it and the male does the display while the female is inside. So here's an example of an avenue bower from a satin bowerbird. And here's an avenue bower from the great bowerbird, a closely related species where that's actually the male, but that's where the female sits during his displays. So the female sits there and the male displays out front. And of course, we know that these are wild displays, lots of songs, and that the male collects all this cool, weird stuff. In the case of satin bowerbirds, a bunch of blue feathers. In the case of great bowerbirds, this is a bower that is entirely populated with fossil shells, right? Those are fossil clams, right? So this is a paleontological bowerbird. So, but now we can see when the male wants to mate, we can see another feature of the bower, which is that the female has to go around from the front, around the walls to mount the female from behind, which gives the female the chance to pop out the front if she doesn't like the way things are going, right? So the bower is beautiful, it's aesthetic, it's a stage for this display, but it also protects the female from forced copulation. How did it evolve? Because females preferred those males who created bowers that provided them with sexual autonomy, right? Essentially insurance against harassment on dates, right? And so she is the agent of selection, and he is, in a sense, the artist here. So then we have to ask, what do females do with their choice? Well, in some cases they choose other kinds of bowers. This is a maypole bower, right, where the male and the female are perched on either side of the bower and move around in circles. And then, so what do they do with their freedom of choice? They choose beauty. And of course, what we know is that there's been an explosive, what I call aesthetic radiation of traits, right? Variations in bower, variation in ornaments, variation in song and display and in plumage, right? What do females use their freedom of choice for? They choose beauty. And so what that means is that freedom of choice begets beauty in nature, right? And that's a profound and I think new insight into the consequences of choice in avian sex, right? Bowerbirds aren't the only example. Here's another one from my old friend, the mannequins. This is a group of displaying male blue mannequin, Chrysophia caudata, in southeastern Brazil. There's 5 of them now, and by the end of this video, there'll be 7. And if you look on the same branch over to the left, you can see the female. She's sitting there observing these displays. Now, these guys are not related. So how is it that they're helping each other, cooperating in display? Well, it turns out only one male will mate with any female that visits this particular. Here's our 7th male, and or 6th or 7th, yeah, there it is, right? And how does that all work? Well, I think it's a matter where the female has selected on those males who get along. Why? Well, why not? She gets to have this is like a group pole dancing display, right? And she gets to decide whether this group or a whole other group of males is the group she prefers, right? How does this evolve? Well, it's because that the males that actually succeed are not those who are dominant, but they are more central to the network. This is data from another Chrysophia species by David McDonald at University of Wyoming, showing that the most successful males are those that are most central. That is the males with the most friends. The females are selecting not on male, but males who are socially connected. And I call this bromance before romance, right? That means that females, right, are selecting on those males who get along and therefore further their own interests in having their own aesthetic needs fulfilled. Right? So this is another way in which female choice has transformed maleness in the birds. So I hope I've convinced you that aesthetic evolution and duck sex, or that duck sex can be, or that bird sex can be aesthetic, that beauty plays a big role in the evolution of birds. But beauty isn't only about birds and only about sex. There are cases like fruits and flowers, which are aesthetic. They appeal, and evolve aesthetically. And nature doesn't just do beauty. Things like the coral snake are actually evolved forms of horror, genres of horror, if you will, in the natural world. right? The coral snake giving aposematism or warning colorations, right? And so this is about this work is connected to a broader diversity of ideas about aesthetic evolution. And if you're interested in this, my 2017 book, The Evolution of Beauty, out in hardback and paperback, and also in 10 translations into 10 other non-English languages. So give it to your friends and check it out, and I'm sure you'll enjoy it. And actually, indeed, it turns out that the last 4 chapters of The Evolution of Beauty are about human sex. So lots of stuff about human sex in there that I think we can learn about from the birds. So I'd love to take questions from anybody in the audience.
Good. Well, we'll do the questions shortly, but I must say thank you very much, Rick. I mean, it's just fascinating just learning about all that stuff. I mean, I didn't know about a mannequin that sang with its wings, for example. I didn't realize that. Fascinating stuff. Just out of interest, do birds in general, do they have sex for the sake of having sex, or is it always when it comes to sort of, the sexual selection to make?
Well, one of the interesting things about birds is that the entire sexual system is incredibly seasonal, right? So the gonads, the testes, and the ovaries of birds change in size several orders of magnitude. So going from the size of smaller than a grain of rice to much larger than a lima bean, right? And this is a huge growth. So every spring in a bird is like adolescence all over again, times 1,000, right? So they really are like not sexual at all during parts of the year, and then they become, highly motivated in those early parts of the year. We know that a lot of that reproduction is not just about breeding, because many birds in migration, if you look at females, they have copulated in migration. So it's a great paper by William Quay on Tennessee warbler in the coast of Texas. So this is a bird that's boreal nesting. It's barely nesting in northern United States and into Canada. And then if you look at the cloaca of females, you find that they've got active sperm in their cloaca in Texas, right? So that means that there's a lot and there's no chance that they're migrating with their mates, et cetera. So they do mate a lot during this short period of the year. And I think that leads in a lot of birds that were considered socially monogamous, right? Where they have a pair at the nest, to a lot of pattern of what to call extra pair paternity or extra pair fertilizations, where females are mating with other males because of this high extreme seasonality.
And the other question that I was thinking about was, you get males that don't breed because they can't find a mate, but aside from population problems, does that ever happen with females? Do all females get hooked up in the end?
Well, it's in the case of ducks, it's very unusual. But I think that the sexual violence and the higher risk of incubating the clutch, which is only female behavior, right, actually leads to higher mortality in females, leading to this initial skew in the sex ratio, right? So it's unlikely that that should happen, frequently in other kinds of birds. One thing that is going on, though, is birds with weird ecologies can be very susceptible, right? I'm thinking of the regent honey eater in Australia, which is a bird that depends on ephemeral resources, nests in one area in one year and one area the next, right? And now their population is so endangered that they may actually be having trouble finding mates because they're at this both highly not migratory, so wandering behavior and low population density. So I think when you get down to low numbers, it can be a real problem, conservation problem. So see, we did talk about conservation.
We did. What species in the world would you like to see in breeding behavior that you haven't seen before, or actually
Well,
copy?
you know, I don't think I've seen even a third of the world species of albatross, right? But if you want to go to sort of the extremity of monogamy, you'd have to say the albatross top it. And there's just so many of them and such great displays where both males and females are displaying. And what's interesting, of course, they mate for a long, long time, but you know, for life, essentially, until one partner dies. They're very faithful. Year after year, but in many of the large-bodied size ones, they can't molt all their wing feathers in less than a year, and so they take off an entire year between mating bouts. So at every colony, there's like an odd year and even year, like cohorts of birds. And so these birds, they only see each other every other year, but they still will mate consistently for like 30 years, right? So that's quite extraordinary, and their displays are something I'd really dearly love to see and don't have enough experience of.
Fantastic. And if you could be anywhere in this world now, Rick, where would you be?
Well, I love South America the most, and I love the Andes. I just love the Chocó, the West Slope. I love Southeast Brazil, one of my favorite places to bird. But one of the places I haven't been in a really long time that I would just dearly love to be, and I would just transport myself if I could right now, would be Suriname in Northeast and South America. Fantastic birds, what an avifauna, and just a beautiful culture. I'd love to spend. I'd love to be in Suriname.
No, I've never. That's the first time we've had that answer, and also I've never been. I don't really know much about the country at all. But fantastic. All right. Well, Zoomers, this is it. There may possibly be another one in April, last minute, but I think we ended on a bang, as I said earlier, right at the very beginning, with Rick Prum tonight. So thank you very much, Zoomers, for turning up. But more importantly, in a way, thank you, Rick, for enlightening us with this fantastic knowledge that I'm sure all of us have been now rushing off to find out more and buy your book, of course.
Thank you very much. Pleasure to be here.
And we will recommence with In Conservation with from October. If you look at the website, there's a whole load of people already lined up to be spoken with, in conversation with. So look out for that. And don't forget, become a member of the Urban Bird of World community, and you'll be able to watch all of the In Conservation with interviews with the Q&As as well. So that's a benefit. So until we meet again, have yourself a great summer, guys, if I don't see you before then. And don't forget, keep looking up.